Welcome to VW 2.1. Today we're going to be talking about imaginary numbers. So you might have heard of this before in your previous class, but today we're going to really go into it. An imaginary number occurs when you have something like this, the root of -1. Now in your previous math class, whenever you had a root of a negative, what happened was you wrote no solution, or if your teacher was very precise, they might have made you write this, no real solution. So today we're going to talk about what that actually means. The root of -1 is actually I. And I represents an imaginary number. So that's why we say no real solution. We're now in the realm of non-real solutions, or we call them imaginary numbers. And if I is root -1, that's powerful because that would mean I squared is simply -1. Now in the realm of imaginary numbers, we often refer to them as complex numbers. So you'll see this a lot in your homework or in the book. Complex numbers have the standard form of a plus bi. Now a is going to be your real component, and b is going to be considered your imaginary component. Now to do a couple problems, or the first examples, they're quite simple. They follow the regular rules of algebra. So you see a 3 and a -2, that's +1. 5i and 3i, that's simply 8i. 1 plus 8i, again, that looks like regular algebra, not that bad. B is the same thing. 6 minus 3, that's 3. 4i minus 6i, that's -2i. So again, notice the regular algebra, nothing crazy has really happened. You could do that with no problem. Here it gets a little bit more complicated. Let's FOIL that term. That's 10 plus 35i plus 6i plus 21i squared. We clearly see our 6i right here and our 35i right here. So 10 plus 41i. But really focus on this I squared. Recall that we said if I is root -1, I squared must be -1, which means this thing can be rewritten as -21 or -21. Now we put together -11 plus 41i is our answer. Here's our next step. Multiplying a complex number by its conjugate. So it says find the product of the complex number, 3 plus 4i, and its conjugate, z with a bar over it. So recall conjugate. If you have a plus bi, and I'll highlight this conjugate here, the conjugate of a plus bi is simply a minus bi, much like our last chapter with the square root. Just switch the sign. And in complex numbers, we say if z is equal to a plus bi, then z with a bar over it, the conjugate, is simply a minus bi. So if I want to multiply 3 plus 4i and its conjugate, let's see what happens. 3 plus 4i times 3 minus 4i, that's going to be 9. The middles cancel, and we're going to get minus 16i squared. And there we go. We see this I squared again. That's -1, which means we get 9 plus 16, which is 25. And again, that might seem like it's pretty easy, but that's actually quite profound, because that means if we do z times the conjugate, or a plus bi times a minus bi, let's really explore that. That's a squared minus b squared I squared, and I squared is -1, which means we get a squared plus b squared. Now you might see it. A squared plus b squared actually is factorable. The difference is we have to use imaginary numbers. So when we said a squared plus b squared was prime, that's only true over the real plane, or the real numbers. If we include imaginary numbers, this actually is factorable. It's right here. So that's a pretty cool use of an imaginary number. So let's do these last two. I'm going to draw a separator here. we treat these just like we would if it were a root on the bottom. So put a note here. We can't have I in the denominator, just like we don't want a root in your denominator. I is the same thing. So let's start in this problem. We're going to multiply by the conjugate of the bottom. That's 5 plus 12i over 5 plus 12i. That means the numerator is going to become 5 plus 32i plus 48i squared. And your denominator should be 25 minus 144i squared. Now, if you're getting good at this, you can go straight to this second step. If you're doing the I squared in your head, that's simply 5 plus 32i minus 48 over 25 plus 144. Now let's put it together. That's negative 43 plus 32i all over 169. Now a lot of people would stop right here. The issue is that would not be correct because of this vocabulary here. Write each of the following in standard form. And recall that standard form is a plus bi, meaning it must be separated into two terms like that. So all we need to do is split the fraction. So this will become negative 43 over 169 plus 32 over 169i. And there's our answer in standard form. We'll do one more example to make sure we got it down. We're going to multiply by the conjugate. I'll do this a little bit faster because I think all of you get the idea here. That numerator should be 8 minus 6i minus 9i squared. Let's just write positive 9. And then 16 plus 9. So 17 minus 6i all over 25. Let's separate them. 17 over 25 minus 6 over 25i. And we are done. Okay, so good luck on the rest of the problems and bring any questions you have to class.